All right, 4-8, day 1. We are going to be doing what's called implicit differentiation. So first of all, we got to talk about the difference between explicit and implicit. So with the derivatives we have been doing have been with explicit equations. So an explicit relation between x and y has the equation y equals, let's say x squared plus 3x. And we would go right into derivative, and we'd say when we're doing the derivative of y with respect to x, we would use that y prime notation and do our derivative rules, 2x plus 3. Okay, well, not all equations are all set up y equals. So when they're not y equals, it's called an implicit relation. Like, say the equation of a circle. X squared plus y squared equals 25. Yes, it's an equation relating x and y, but it's not set up y equals. So we want to know, how do we do the derivative of something like this that's not y equals? So there's 3 steps to follow. So implicit differentiation steps. Differentiation steps. So you're going to go through and do derivative normally. So you take so you're going to differentiate x terms normally. Nothing changes when you come across an x term. Now when you come into the y terms, you're going to differentiate y terms just like it's an x, so normally. And one extra thing, you're going to multiply that term by y prime. Multiply, not fly, multiply that term by y prime. So it's possible that you have more than one term in your implicit relation that has a y in it, so you might have more than one y prime. So we got to do a little algebra now. So the third step is to isolate all y prime terms onto one side of the equation so you can get them all to the left side or all to the right side, it doesn't matter. Then factor out the y prime. So this will be like basket factoring, where we're only taking out the y prime and then solve for y prime. So again, it's an algebra heavy day. So let's take a look at doing one implicitly, and we'll compare it to the explicit and show that they do come out the same. So this one will be a little extra work, but then I'll have done my job and shown you that they're the same. So our first example, let's start with the implicit relation 2x squared minus 3y squared equals 5. So we want the derivative. So we leave it just like it is. Derivative here, little power rule, we'll have 4x to the first minus, now I'm doing the derivative here, so again it's a little power rule, so that 2 comes down, that'll give us a 6 y to the first, but like I said, the and is to multiply that by the y prime. So anytime you do the derivative of the y, you got to stick a y prime with it. Equals, and then the derivative of 5, that's a constant, that goes to 0. So now we got to get it to y prime equals. So when we do derivative, we want it y prime equals. So that's the part where we're at. So the third step was to isolate all y prime terms on one side. I'm just going to add this term over to the other side with the 0. That'll get the y prime term over there. So we will add 6y y prime to both sides of the equation. That will leave us with 4x equals 0 plus 6y y prime. Since there's only one term, there's no factoring to do. So to solve for the y prime, all I've got to do is divide by 6y on both sides. And then simplify. The 4 and the 6 reduce each other. I'll have 2x over 3y. Okay. To show you that this is the equivalent to doing it the explicit way, I want to start with that same equation. So we'll start with 2x squared minus 3y squared equals 5. So what we're going to do is get this to y equals before we do derivative. So we're going to subtract the 2x squared from both sides. That will leave a negative 3y squared equals 5 minus 2x squared. Divide by the negative 3. I'm going to separate those so I don't have to do a quotient rule. That will leave y squared equals, I'll have a negative 5/3. This will become a plus 2/3 x squared. And the last thing I've got to do is get rid of the squared, so that means I'm going to raise to the 1/2 power on both sides. So my equation is y equals this whole thing to the 1/2 power. So doing our derivative, y prime equals. So I've got an outside and an down times this quantity to the 1 less, that gives me negative 1/2, multiplying by the inside, this is 0, and this derivative will be 4/3 x. So in simplifying, this 4/3 x is going to come to the front here, and that will, let's see, the 2 and the 4 will reduce. So that will give us 2/3 x. And then if I make this a happy exponent, that's going to go into the denominator. Oh, actually, I'm going to leave it like it is. 2/3 x, and then it'll be negative 5/3 plus 2/3 x squared to the negative 1/2. Okay. So right now, those two derivatives don't look much alike. This one's got all this mumbo jumbo. This one's got 2x over 3y. The reason they don't look alike is because this one has a y in it yet. So what I need to do is just substitute y, and right here is where I have the original y. if I put that in place of that, you can see with a little imagination that it is equivalent to this. So let's do that. So we have 2x over the 3 is down there, and the y gets this negative 5/3 plus 2/3 x squared to the 1/2. So if you think about it, this 2x is right here, 2x. The 3 is in the denominator, and this, because it's got the negative 1/2, would come down with the 3 and be to the 1/2 power. So they are equivalent. So are we going to have to do that, substitute the y back in? No. We are going to be leaving our derivatives in terms of x and y. So a couple more examples just to practice with some more terms. Number 2. Here's our implicit. We've got the equation 2xy plus y squared equals 3. So here's one that has 2 y terms in it, so we're going to be having 2 y primes. Alright, so this is the first term. We got to do derivative, and what you need to pick up on is that we have essentially 2 variable terms multiplied, so this is going to be a product rule. I'll let the 2x equal the u and the y equal the v. So I've got a u times v here, so product rule it is. So product rule says take the derivative of the first term, which is 2, multiply by the second term, plus keep the first term, multiply by the derivative of the second term, and it's just a y. Derivative of y is 1. Not that you need that. And then remember, anytime you're doing the y terms, you got to multiply by the y prime. So product rule is done. Continuing on, derivative here is going to be 2y to the first times the y prime. 2y times the y prime. Derivative of 3 is 0. Alright, derivative's done. It's all of our algebra. Second step said get your y prime terms to one side. I've got 2 terms that have a y prime. I'm going to leave them here. Move the one that doesn't have a y prime to the other side. So I will subtract 2y. So that leaves, I'll take baby steps here, plus 2y, y prime equals a negative 2y. And now there's 2 baskets. We're only going to basket factor out the y prime. I don't want to take the 2 that's common, just the y prime. So basket factor out the y prime. That leaves 2x plus 2y. And now to get y prime by itself, we just got to divide by that whole group. And if you look at your 3 baskets, there is a common factor of 2 that needs to get canceled. So that'll be down to negative 1, 1, 1. So our final derivative is going to be a negative y over x plus y. And do not cancel those. All right, we are at our last example already. But we're going to add to it. We're going to do derivative and find the equation of the tangent line. So our equation is x cubed y to the 5th plus 2x equals 34. So we're and find equation of the tangent line. We haven't done it in a while. At the point 1, 2. Okay, So, again, just like example 2, you got to pick up on the fact that this is a product rule here because there's two variables multiplied together. So, product rule. Derivative of the u is 3x squared times by the v term plus, keep this, derivative of y to the 5th will be 5y to the 4th by the y prime plus, derivative here is 2, 0. So looking, there's only one y prime term, and there are two that don't have a y prime, so I'm going to move this one term over here. So I will be subtracting 5x cubed y to the 4th y prime. Remember, these are all multiplied, so it is proper to bring the 5 to the front. So we have 3x squared y to the 5th. Still have a plus 2. And then the negative 5x cubed y to the 4th y prime. So no factoring needed. So all I got to do is divide by this chunk that's being multiplied by the y prime. So there's our derivative. Now, derivative is done. We want the equation of the tangent line. So, equation of a line requires slope. Remember, slope is the derivative value. So, I need to plug into this derivative to see what the slope is. Well, this time my derivative has to have x and y substituted in, but lucky for us, they gave us x and y. So wherever I see an x, I'm putting a 1, y gets a 2. So the slope is the y prime value, so it's 3 times 1 squared times 2 to the 5th plus 2, all divided by negative 5, 1 cubed, 2 to the 4th. Okay, so let's see, 2 to the 5th, I think that's 32. 2 times 2 is 4, times 2 is 8, times 2 is 6. 32 times 3, I don't have a calculator in here, let's see, 6, that's 96, plus 2, that's 98. Let's see, that was 16 times a negative 5. That's the 80. And we have a negative, I'm just going to float that to the top. Looks like they're both even. I can divide them by 2. I'll have a negative 49 over 40 as my slope. Now we just need to figure out the b. So if we go into y equals mx plus b, I got the m. I've got an x and y. That'll let me solve for the b. So the y is 2. The m is negative 49 40ths. The x is 1 plus b. So all I've got to do is add 49 40ths to 2. So that will be 80 plus 49, 129. So 129 over 40. Well, that's ugly. So our equation of our tangent line, negative 49 40th x plus 129 40ths. Okay, there's implicit.